In this example, we're working in section 7.8 to find the inverse of a 3 by 3 matrix. And the way we set these up is we start out with a system where we have A followed by I, and then we have then we perform elementary row operations following the Gaussian elimination type procedure to convert this to the form that the left side becomes transformed to the identity matrix, which will leave the right half the inverse of the matrix of the original matrix. So that's the procedure that we're going to use here. So in our case, that means we start out with 1, 1, 1, 2, 1, minus 1, minus 1, 0, 1. And on the right half, we put in the identity matrix. That's a 3 by 3. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we'll start off using the same type of steps that we normally use in Gaussian elimination. Our first target is the 2 that leads off row 2. So we'll take minus 2 times row 1 and add that to row 2, and that's our new row 2. So keep row 1 the same. And for row 2, we have minus 2 times the original row 1 plus the original row 2, so we get 0. Minus 2 times 1 plus 1 is minus 1. Minus 2 times 1 is minus 2. Minus another 1 is minus 3. Minus 2 times 1 plus 0 is minus 2. Minus 2 times 0 plus 1 is 1. Minus 2 times 0 plus 0 is 0. Then, for the third row, we take the original row 1 plus the original row 3, and that will get rid of the leading minus 1. So we put 0, then 1 plus 0 is 1, then 1 plus 1 is 2, then 1 plus 0 is 1, 0, 1. Okay, so for our next step, I need to make some room. So what I'm going to do is transform this now to the next step. So we'll keep row 1 and row 2 the same. 1, 1, 1, 1, 0, 0, 0, minus 1, minus 3, minus 2, 1, 0. Now, what we're going to put in the new row 3 will be our old row 2 plus the old row 3, and that will make it be the first two terms, leading terms will be 0. Then we'll continue this. The old row 2 plus the old row 3 is minus 3 plus 2 is minus 1. Minus 2 plus 1, whoops, minus 2 plus 1 is minus 1. Minus 2, sorry, 1 plus 0 is 1. 0 plus 1 is 1. So we've got that step completed. And what I'm going to do now is recognize that the bottom row is nearly ready. It just needs to be multiplied by negative 1. So I'm just going to keep row 1 and 2 the same. And in my next single step, what I'm going to do is I'll just take minus 1 times row 3 to get me to where I need to go. So that's our next step. I'll make room for more. So now in our next step, what I'm going to do is I'm going to now target the minus 3 and the 1 that we have above the final 1. Sorry, this 1 in row 3 right here is what we needed to get to. Directly above it, that minus 3 and the 1 above that now need to disappear and become zeros. So in this step, that's what we're going to work on. So row 3 will stay the same, 0, 0, 1, 1, minus 1, minus 1. By the way, we do have that 1 minus 1 minus 1 is the bottom row of the inverse matrix. But let's keep going. So to get rid of the minus 3, we're going to take 3 times the previous row 3 and add it to row 2. So that's 0, minus 1, 0. 3 times 1 minus 2 is 1. 3 times minus 1 is minus 3, plus 1 is minus 2. 3 times minus 1 plus 0 is minus 3. Okay, so we got our row 2 transformed to what we wanted to, but now we want to get rid of the third one in row 1. And to do that, we're going to take the old row 1 minus the old row 3. So it's 1, 1, 0. The old row 1 minus the old row 3 is 0 here. The old row 1 minus row 3, the old row 3 is 1. So that's minus a negative 1. And we have the same result here. So that's the next step transformed. For our last step, what I'd like to do is, we're getting close to the end here. What I want to do is take this row 2, I'm going to take this row 2 and this row 1 and add them, and that'll help us get rid of that number 1. So the old row 2 plus the old row 1 is going to be my new row 1. So I get 1, 0, 0, 1, minus 1, minus 2. And for the new row 2, I'm just going to take the old row 2 times minus 1. 0, 1, 0, minus 1, 2, 3, and the old row 3 is the new row 3. And in fact, we are done. This is our inverse matrix, and I know that because this is our identity matrix. So I can say that A inverse is equal to 1 minus 1 minus 2 minus 1, 2, 3, 1 minus 1 minus 1. And if I'd like to check that, what I can do is take the original row matrix A and multiply it by our inverse that we just found, and make sure we get the identity matrix. Our original matrix started off with 1, 1, 1, 1. The second row was 2, 1, minus 1, 2, 1, minus 1, minus 1, 0, 1, minus 1, 0, 1. And we're going to multiply that by our A inverse. 1, minus 1, minus 2, minus 1, 2, 3, 1, minus 1, minus 1. And check to see what we get. To start off, I'm just going to perform the matrix multiplication. So first row times of A times the first column of A inverse gives me 1 minus 1 plus 1, and that sums to 1. Now I take the first row of A multiplied by the second column of A inverse to get minus 1 plus 2 minus 1, and that's 0. Then the first row of A times the third column of A inverse gives us minus 2 plus 3 minus 1, or 0. For the second row of the product here, we take the second row of A multiplied by the first column of A inverse to get 2 minus 1 minus 1, which is 0. Then for the next component we have 2 times minus 1 for minus 2 plus 2 plus negative 1 times negative 1, and that result is 1. Oops, didn't draw that very well. That result is 1. And then for our last component on that row, we have 2 times minus 2 for minus 4 plus 3 plus 1 is 0. And for the last row, we're taking the third row of A, multiplying by first the first column of A inverse, and then we get minus 1 plus 1, 0. Then we get negative 1 times negative 1 for plus 1, minus 1 is 0. Then we take minus 1 times minus 2 to get plus 2 times, plus 2 minus 1, 1. And we did get the identity matrix, so indeed this is the correct answer. We did successfully find the inverse of A as shown.